So let me draw some things here. All right. So I'm just going to draw the longs as rectangles because that makes it a little bit easier than trying to draw them out anatomically. Okay. So there's my lungs. All right. And let's see, here's my trachea, and here are going to be my bronchi going into each lung. All right. And then surrounding that, we're going to have our thoracic cavity. So let me just draw my little person here. And then down here at the bottom, we have our diaphragm. Oops. All right, so there's our diaphragm. All right, so then we've got all of this air outside. So when air comes in, here's what happens to make air come into the lungs. So here's our diaphragm down here at the base of the lungs. What's going to happen is that the diaphragm is going to basically contract here. And what that does is it opens up the space in the thoracic cavity. It expands the volume of the thoracic cavity. So the volume increases, okay? Within the thoracic cavity, we have more space. We have more volume, more area here within the thoracic cavity now. We basically made it larger, okay? Thoracic cavity volume increases. So here's where that law of chemistry comes in. It's called Boyle's law. Oops. And what Boyle's law says is that if we increase volume, we get a decrease in pressure. Okay, so if volume increases, pressure is going to decrease. Okay, and then we have the opposite of that. If we decrease volume, we increase pressure. All right, so what has happened? We've increased the volume. Okay, so now thoracic cavity pressure decreases. Okay, so with that increase in the volume, okay, we are now decreasing pressure. Well, what does that mean? What does that have to do with anything? Well, we're talking about the air pressure. Okay, so now the air pressure in the lungs is less than the air pressure outside. So outside in the environment. Air is going to flow from higher pressure to lower pressure. So now, so what are we saying? So our air pressure is lower here in the lungs than it is outside. So what's going to happen? Well, air is going to flow in. Okay. So air is going to flow in to the lungs. Oops. Okay. Air flows from a higher pressure to a lower pressure. We've now made the pressure in the thoracic cavity lower than what's outside in the environment. So air flows in. Okay, so that's the process of inspiration. It all starts because the diaphragm contracts. Okay, now, eventually the diaphragm is going to relax. Okay, so let me erase some of my stuff here. All right, so now the diaphragm relaxes. So diaphragm is going to kind of come back up like this. Well, then everything that we've talked about here is going to be in reverse. So when the diaphragm relaxes, the thoracic cavity volume decreases, okay, which means that thoracic cavity pressure increases according to Boyle's law, which is what we have defined. So now the air pressure in the lungs is greater than outside. So air, again, flows from higher pressure to lower pressure, so air flows out. Okay, so when the diaphragm relaxes, air is going to flow out. So now air flows out of the lungs. So that's expiration. So this entire process is governed by Boyle's law. And it all has to do with what the diaphragm is doing down here. If it's contracting, air can flow in. If it's relaxing, air is going to flow out. Okay. You know, a lot of people think about the lungs as basically like balloons. And a lot of times when we do experiments and we, use illustrations to represent the respiratory system, we use balloons to represent the lungs. But the lungs are not hollow. They don't function just like balloons do. We have to create a situation that makes air enter into those alveoli. And this is what's going to do that. It's all dependent upon pressure and volume.